Hello. So, good afternoon, everyone. The students are still joining, so we'll wait for some time. So, yesterday we have seen the Poisson's and Laplace's equation. Can anyone tell me what is the Poisson's equation? What is Poisson's equation? Del square V is equal to
minus rho v upon epsilon.
minus rho V upon epsilon, correct. And when this rho V becomes 0, right, then this del square V is equal to 0, and it is called which equation?
Laplace.
Laplace equation, correct. Then we have seen the del square operator, right? Del square operator in different coordinate systems. Okay, and on that they can ask you example. Okay, so no one is asking you formula there. Okay, formula is not asked, but they're asking you examples. But if you consider the MCQ questions, that time sometimes they may give you the simple formula, not like this, but simple formula they may ask you. So you have to remember. Means, for example, del formula also they can ask you the del operator formula. I think once that question is asked in examination, but you prepare for all. And we have seen the point conversion, right? Na? Point conversion means if any coordinate is given in one coordinate system, suppose R is given in cylindrical system, and if you want to convert that into suppose spherical coordinate system, then what should be the formula? Okay, likewise such questions are asked in examination. So remember all these formula. Okay. So some students are joined. So we'll start with the new point today. So screen is visible. Yes.
Yes, ma'am.
Visible now. So the next point is dielectric materials. Dielectric materials. Can anyone tell me? Someone asked me on that day the question, what is mean by these dielectric materials? So the dielectric, when we were seeing that conductors, and I told you that these conductors are having the moving electrons, right? Now, they are having the free electrons. That's why these electrons are moving, and so that the current is flowing through the conductor. Okay, that's why it is a conductor. Means free electrons are available in the conductor, but it is not in the dielectric material and in the insulators also. Okay, means no free electrons are available there. Then how the current will flow? Right? Okay, the current cannot flow through this dielectric materials. Okay, means it is a neutral. Okay, it is a neutral point, we can say. Okay, means no free electrons are there. All charges are bound there. All charges are bound there. Means no free electrons, so no current is flowing through the dielectric materials also, right? And this dielectric material is nothing but the material you can imagine the capacitor which is having two parallel plates. Okay, the capacitor is having two parallel plates, and in between that some insulating material, that is nothing but a dielectric material is there. Okay, dielectric material is there. If you have studied all of you studied the capacitor in basic electrical engineering or any other subject, some electronic subject, how actually that capacitor is working. So when the supply is given to the two plates of that conductor, two plates of that capacitor, that time what happens there? That dielectric material get break there. Okay, break there. So the current is flowing through that capacitor, right? That is means when we are applying some external supply, when we are giving some external supply, then these electrons become free there, and somewhat current is flowing through such materials. That is nothing but a dielectric material. Okay, so just imagine it is just like your insulator and insulator. So these dielectric materials are not having the free electrons. Okay, just like our conductors. Conductors are having the number of free electrons, but it is not for the dielectric materials. Okay, so here it is given the conductors have large number of free electrons, while insulators and dielectric materials do not have such free charges. Okay, means no free charges are there. That's why the current is not flowing through these dielectric materials. And the charges in dielectrics are bound by a finite forces and hence called the bound charges. Okay, means no free electrons. Okay, no free electrons. That's why these are called the bound charges. Okay, these are called the bound charges, and these are bound by a finite forces. Okay, so as they are bound and not free, they cannot contribute to the conduction process. Okay, जे free electrons नाही आहेत तर conduction होईल का, current flow होईल का, नाही, right? So there is no any conduction process. But if subjected to an electric field, they shift their relative position against the normal molecular and atomic forces. So this shift in the relative positions of bound charges allows the dielectric to store the energy. Okay, so what happens? And they are not having their own electrons, but what we are doing, we are giving the external supply. We are providing the electric field there, E bar. Okay, जर supply दिला तर काय होतं? All of you may know, if you give an external supply to the insulator also, then also some electrons get free there. Okay, all of you may have heard about that. But like this, but the number of electrons here will become free when you are giving supply are more in dielectric material. Okay, म्हणजे dielectric material हे insulation पेक्षा थोडी above category. Okay, you can consider first conductors, then dielectric materials, and then your insulators. Okay, likewise. So when we are giving external field or electric field, then the whatever be that atom is there, so their molecular structure get changed, means the free electrons will be available now. Free electrons will be available now. Okay, and it will also store the energy. Okay, the capacitor is used to store energy. Okay, so in terms of what? In terms of what? Your capacitor stores energy in terms of voltage, and your inductor stores your energy in terms of current. Remember this. Okay, so the shifts in the positive and negative charges are in opposite directions. Okay, are in opposite directions and under the influence of an applied electric field E bar. Okay, so when we are giving supply, when we are giving supply, what happens? The position get changed. Okay, the position of the charges get changed. So when this there is a shifting of this positive and negative charges. Okay, when there is shift of this positive and negative charges in opposite direction, and at that time we are applying electric field, then and then only their position get changed. Okay, so such charges act like small electric dipoles. Okay, okay. So what happens here? When we are giving the supply, the charges change their position. The charges change their position. So when they change the position, okay, they are forming an electric dipole. Okay, they are forming the electric dipole. So what is mean by this electric dipole? Electric dipole is nothing but a charge. Okay, there are two charges which are placed at the opposite direction with the same distance from the center. Okay, we have seen the electric dipole and its a derivation, right? So these are nothing but there is one center on positive z axis, one charge plus q was there, and on negative z axis there was minus q charge. Means their magnitude is same, only the direction is different. Okay, so when this shifting shifting happens when we are applying this electric field, that time they are making the electric dipoles. Okay, small electric dipoles. So this process, due to which separation of bound charges results to reproduce electric dipoles. Okay, म्हणजे जेव्हा आपण इलेक्ट्रिक फील्ड अप्लाय केल्यानंतर ते चार्जेस, बाउंड चार्जेस जे आहेत ते काय होतात, सेपरेट होतात अँड दे आर फॉर्मिंग अन इलेक्ट्रिक डायपोल. सो अंडर द इन्फ्लुएन्स ऑफ इलेक्ट्रिक फील्ड, अँड दॅट is nothing but the polarization. That process is nothing but the polarization. So all of you understood what is mean by this polarization? पोलरायझेशन म्हणजे काय? तर जेव्हा आपण डायइलेक्ट्रिक मटेरियल आहे एक्सटर्नल फील्ड अप्लाय करतोय. ओके, एक्स्ट्रा फील्ड इलेक्ट्रिक फील्ड अप्लाय करतो का? तर ऍक्च्युली त्याच्यामधून करंट फ्लो होत नाहीयेत, फ्री इलेक्ट्रॉन्स नाहीयेत, म्हणून आपण काय करतोय, तर एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाय करतो. फील्ड अप्लाय केल्यानंतर काय होतंय, तर त्याच्यामध्ये जे बाउंड चार्जेस आहेत, म्हणजे फ्री नाही आहेत, ते बाउंड चार्जेस आहेत, तर ते काय होतात, तर सेपरेट होतात. ओके, सेपरेट होतात, त्यांची पोझिशन शिफ्ट करतात. ओके, तर ते जे बाउंड चार्जेस आहेत, तर ते बाउंड चार्जेस शिफ्ट झाल्यानंतर काय प्रोड्यूस करतात, इलेक्ट्रिक डायपोल प्रोड्यूस करतात, स्मॉल डायपोल प्रोड्यूस करतात. ओके, ही जी सगळी प्रोसेस आहे डायपोल प्रोड्यूस करण्याची, त्या प्रोसेसला काय म्हणायचं, polarization. Okay, polarization. So I hope everybody understood this. Sometimes these questions are asked in examination, but very few times. Next point is the properties of dielectric materials. Okay, properties of dielectric materials. So the dielectrics do not contain any free charges but contain bound charges. Okay, dielectrics do not contain any free charges. No free charges are there, but it contains only the bound charges. Then bound charges are under the internal molecular and atomic forces and cannot contribute to the conduction. So these bound charges are under internal molecular and atomic forces. Okay, this they are bound. Okay, and there are atomic forces which are not separating them. Okay, and they cannot contribute to the conduction. That's why no conduction process is there. So when subjected to an electric field, the bound charges shift their relative positions. Okay, when we are giving electric supply or electric field, when we are applying, these bound charges are shifting their positions, and due to this, small electric dipoles get induced. Okay, inside the dielectric, and this is called the polarization. Okay, now due to polarization, okay, due to polarization, the flux density of the dielectric increases. Okay, flux density increases by amount equal to the polarization. Okay, can anyone tell me how the flux density is increased there? How the flux density is increased? Flux density means what? The number of flux passing through the given cross-sectional area, right? That is nothing but the flux density. Polarization happens means what? There is again the movement of the charges, and when there is a movement, the flux get produced there, and therefore that flux density will be more if there are number of polarized atoms are there. So its flux density will also be more. Okay, flux density of the dielectric increases by amount equal to the polarization. Okay, now the induced dipoles produce their own electric field. Okay, the induced dipoles produce their own electric field and align in the direction of applied electric field. Okay, so when these dipoles are produced, these dipoles are producing their own electric field. Okay, own electric field. म्हणजे समजतंय ना? Yes. If it is when one conductor you are considering, that conductor is also having its own electric field. Okay, when you are applying, that is okay, that is the applied electric field, but due to the movement of these electrons, again the field will be developed. That is, they are having the own electric field and align in the direction of the electric field, applied electric field. Okay, and they will be, or they will move in the direction of applied electric field, just like your conductor. Okay, so when you are applying some external field, electric field, then what happens? The direction of the electrons get changed there. Likewise, here also the direction get changed as per the supply. Okay, and when polarization occurs, the volume charge density is formed inside the dielectric, while the surface charge density is formed over the surface of the dielectric. Okay, so when this movement occurs, okay, or when the separation of the charges occur, that time the volume charge density is formed. Okay, volume charge density means whatever that material you are considering, okay, there will be charges. Okay, म्हणजे तुम्ही एखादा स्फिअर कन्सिडर केला तर त्याच्यामध्ये जे काही बाउंड चार्जेस होते, ते बाउंड चार्जेस आता काय झाले तर मूव्ह करायला लागले. ओके, जे काही पोलरायझेशन झाले, तर त्या पोलरायझेशन मुळे त्याच्यामध्ये त्या व्हॉल्यूम मध्ये काय झालं, चार्ज क्रिएट झालेत. बरोबर, डिफरंट चार्जेस अँड दे आर हॅव्हिंग द डेन्सिटी. ओके, दॅट्स वाय the volume charge density is formed. And also, if you consider the surface of that sphere, on that surface also there is a surface charge density. Okay, is formed over the surface of the dielectric. Now the electric field outside and inside the dielectric gets modified due to an induced electric dipoles. Okay, so the field is developed inside that volume and outside that volume. Okay, so the electric field outside and inside the dielectric, or I'm giving you example of sphere only. Okay, inside the dielectric, it gets modified due to induced electric dipoles. Okay, means all their what we can say, that material gets changed there, means all properties get changed there. Okay, means from non-conducting it becomes conducting now. Now we have seen the polarization. So polarization means what? So when we are giving electric supply, then what happens? When we are giving electric supply, these bound charges get separated, and when they get separated, they are forming the dipoles. Okay, electric dipoles, small electric dipoles, and that process is nothing but polarization. Okay, so that polarization is explained here. Okay, so you can consider one atom here. You can consider one atom. So nucleus is there and there are electrons. So that is called the electron cloud. Electron cloud is there. Now just tell me, at first when you are not applying any electric field, are there any free charges, free electrons are there? Yes or no? Any free electrons are available or not there when you are not applying the electric field? Yes, anyone? When you are applying an electric, when you are not applying an electric field, are there any free charges available in that atom?
No.
No, no free charges are available. Okay. So it is shown here. No free charges are available here when you are not applying any electric field. So here consider an atom of a dielectric. Okay. This consists of a nucleus with positive and negative charge. Nucleus is there, positive charge, negative charge, and these are revolving in the form of negative charges in the form of revolving electrons in the orbits. Okay, so negative charges are there. The negative charge is considered to be in the form of cloud of electrons. So it is already shown here. E bar applied is 0. Okay, means we are not giving any external electric field. Okay, that time these all charges are bound charges. Okay, when you are not applying any electric field, these charges are bound charges, no free electrons. Okay, means the number of positive charges is same as that of negative charges, right? Hence the atom is electrically neutral. Okay, neutral asnare. Now due to symmetry, both positive and negative charges can be assumed to be point charges. Okay, of equal amount and coinciding at the center, and hence there cannot exist an electric dipole, and this is called unpolarized atom. Okay, so as the number of positive and number of negative charges are same, and when we are considering this as a point charge, okay, point charges of same magnitude, and they are coinciding at the center only, at the center. So means there is no that particular distance, okay, from the center between the positive and negative charge. Okay, between positive and negative charge, that time this atom is unpolarized. This atom is unpolarized. So when it becomes polarized, when you are giving the external electric field, or when you are applying the electric field. So here, when electric field E bar is applied, okay, when electric field E bar is applied, the symmetrical distribution of charges get disturbed. म्हणजे काय होतं आधी, नंबर ऑफ पॉझिटिव्ह चार्जेस इज इक्वल टू नंबर ऑफ निगेटिव्ह चार्जेस. ज्यावेळी आपण इलेक्ट्रिक फील्ड, एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाय करतो, तर त्यावेळी काय होतं, ते जे त्यांचं डिस्ट्रीब्युशन आहे ते काय होते, चेंज होत आहे. इट गेट डिस्टर्ब. सो द पॉझिटिव्ह चार्जेस एक्सपिरियन्स ए फोर्स F bar is equal to Q into E bar. So we have seen this equation also in second chapter. F bar is equal to Q into E bar, right? When we obtain the electric field intensities equations for electric field in intensity, and when we consider different types of charges, okay, sheet charge, surface charge, etc. So that time we have seen this. So when we are applying that electric field, that position of the charges get changed. So the positive charge experience a force of F bar is equal to plus Q into E bar. Okay, remember this. So F bar is equal to plus Q into E bar, while the negative charges experience a force of F bar is equal to minus Q into E bar. Okay, in opposite direction. Okay, in opposite direction. So all of you understood this? Positive charge is experiencing the force of Q into E bar, and negative charge is experiencing a force of minus Q into E bar. Okay, in opposite direction. And now there is separation between the nucleus and center of the electron cloud. Okay, म्हणजे ज्या तो फोर्स अप्लाय होतो, जेव्हा तुम्ही इलेक्ट्रिक फील्ड अप्लाय करता, इलेक्ट्रिक फील्ड म्हणजेच काय, इलेक्ट्रिक फील्ड इंटेन्सिटी म्हणजेच काय, तर तुम्ही काहीतरी फोर्स अप्लाय करताय ना. म्हणजे फॉर एक्झाम्पल, इफ यू कन्सिडर द कंडक्टर, so if you keep the conductor without any electric field, so just tell me how what is the flow of electrons in one direction only, or they are moving randomly. कसं असते, ज्यावेळी तुम्ही फील्ड अप्लाय करत नाही, इलेक्ट्रिक फील्ड अप्लाय करत नाही, तर तेव्हा कंडक्टर मध्ये इलेक्ट्रॉन्स कशी फ्लो होतात, randomly flow hota, randomly, right? So when you are applying electric field, they get direction. Okay, how they are moving, what is the direction of electron flow? They are moving from positive terminal to negative, negative to positive,
negative to positive.
Negative to positive. That is the electron current. Your conventional current is flowing from positive terminal to negative terminal, but your electron current is from negative terminal to positive terminal, right? So remember these small things. Okay, so when there is separation between this nucleus and center of electron cloud, such an atom is called polarized atom. ओके, म्हणजे जेव्हा ते दोन सेपरेट होतात, म्हणजे पॉझिटिव्ह आणि निगेटिव्ह चार्जेस, तर ते काय फॉर्म करतात, तर डायपोल फॉर्म करतात. आणि डायपोल फॉर्म झाली की त्या प्रोसेसला काय म्हणतात, तर पोलरायझेशन. आणि मग तो जो ऍटम तयार होईल त्याला काय म्हणायचं, पोलराइज्ड ऍटम. सो हियर that dipole is shown, the minus Q charge is there, plus Q charge is there, and there is a small distance between these two charges. This is nothing but the polarization. Okay, so here you can see the center of electron cloud is there when we are applying electric field, nucleus, and there are some electrons. So they are changing their position. And they are forming an electric dipole. Okay, so here an electron cloud has a center separated from the nucleus, and this forms an electric dipole, and the dipole get aligned with the applied field. Okay, म्हणजे जसं तुम्ही field apply कराल तसं dipole form होणार आहे. Okay, in this way your dipole will be formed, and this process is called the polarization of dielectrics. So polarization concept is sometimes asked in examination. It is for 4 marks they are asking, and this is the theory question from your whole what we can say whole EME only. This is that much theory is only there. Okay, otherwise all derivations. Okay, so समजले सगळ्यांना? Yes or no? All of you understood this? What is mean by dielectric material? What is mean by polarization? Yes?
Yes, ma'am.
Okay. Now, next point is mathematical expression for polarization. Actually, this polarization we studied. So when the dipole is formed due to polarization, there exists an electric dipole moment. Okay, so we have seen the dipole and electric dipole moment equations when we studied this in second chapter only, electric dipole and electric dipole moment. So for electric dipole, the equation is different, means we are finding the electric field intensity there. Okay, and the equation means we can write the electric field intensity equation and the potential equation for the electric dipole. And when we are considering the dipole moment, okay, that is P bar, it is given by P bar is equal to Q into D bar. हे equation आपण already derived केलेला आहे. Okay, so this P bar, an electric dipole moment, is given by P bar is equal to Q into D bar, where this Q is the magnitude of one of the two charges. Okay, of one of the two charges. So why we are considering magnitude of any one charge? What about the second charge magnitude? So can anyone tell me? Then I can say you understood the concept of an electric dipole. So all of you got my question? Why here the magnitude of only one charge is considered? Why not of second charge?
Q ची मॅग्निट्यूड हे 2 चार्ज मध्ये घेतली मॅडम, आणि ते 2 चार्जला वेक्टर आहेत ना, ते मग वेक्टरचा प्रोडक्ट हे होतं, स्केलर होतं म्हणून.
Scalar. Okay. So anyone else? Dipole means what? Remember, dipole means two charges having same magnitude, only separated by a small distance. Okay, दोन्ही charges ची magnitude कशी आहे? Same आहे. That's why here the Q is taken, means it is the magnitude of any one of the charge. Okay, म्हणजे प्लस क्यू असू द्या मायनस क्यू असू द्या, मॅग्निट्यूड कशी आहे? सेम आहे. म्हणजे सपोज वन चार्ज इज ऑफ 10 मायक्रोकुलम. ओके, सो प्लस क्यू इज नथिंग बट प्लस 10 मायक्रोकुलम and minus q is nothing but minus 10 microcoulomb. Magnitude is same for the charge in electric dipole, only your position changes here, there. Okay, and this d bar is the distance vector from negative to positive charge. Okay, from negative, okay, remember from negative charge, that is minus q, to plus q charge. Okay, that is the distance, total distance. Okay, now so consider here n is equal to, small n is equal to number of dipoles per unit volume. Okay, म्हणजे what I told you, suppose there is a dielectric material, we don't know the shape. So that's why what I'm considering, that there is one sphere, in that there is a dielectric material. Okay, so you can imagine that as a volume. Okay, so if n is equal to number of dipoles per unit volume, means in that volume, in that sphere, when you are applying the electric field, the number of dipoles are formed there. Okay, number of dipoles are formed, and delta V is equal to total volume of the dielectric. Okay, delta V is the total volume of that dielectric, and capital N is the total dipoles. Okay, total dipoles. So small n is the number of dipoles, and capital N is the total dipoles formed in that volume. Okay, so which is equal to n into delta V. ओके, म्हणजे टोटल डायपोल्स किती असणार आहेत, किती डायपोल्स आहेत त्या व्हॉल्यूम मध्ये. ओके, तर टोटल व्हॉल्यूम किती आहे, डेल्टा व्ही, आणि किती डायपोल्स आहेत त्याच्यामध्ये, तर n डायपोल्स आहेत. ओके, सो द टोटल डायपोल्स इज इक्वल टू n into delta V. Okay, now then the total dipole moment is to be obtained using the superposition. Okay, it is simple. So if you want to find the total dipole moment, so this P bar total is equal to Q1 D1 bar plus Q2 D2 bar plus up to so on Qn Dn bar. Okay, so this P bar total is equal to summation from I is equal to 1 to the total number of dipoles, that is n into delta V of this Qi into Di bar. Okay, Di bar. Okay, so to find the total dipole moment, you have to take the summation. You have to take the summation, and limit will be from 1 to n into delta V, which is nothing but the total number of dipoles. Okay, so if the dipoles are randomly oriented, this P bar total is 0. But if the dipoles are aligned in the direction of applied E bar, then P bar total has a significant value. Okay, म्हणजे means what, when we are not applying field, okay, means or when you are applying the field, that time whatever be the dipoles form, yeah, but if they are not in the particular direction, if they are not having a particular direction, means they are randomly displaced, that time that dipole moment is equal to 0. But when you are applying a particular direction E bar, okay, means when you are applying E bar in a particular direction, then that P bar will be available there. Okay, so the polarization P bar is defined as the total dipole moment per unit volume. Okay, so this P bar is equal to polarization for this P bar is equal to P bar is equal to limit as delta V tends to 0 of this P bar total divided by the total volume, and its unit is coulomb per meter square. Okay, coulomb per meter square. So can anyone tell me how this unit is coming? So how are you finding limits? How are you finding units? How to find unit? From given data only, na, you can find the unit. Or you remember every every terms unit? Is it possible in EME to remember every terms unit? So in examination, can you remember the unit of this P bar? So just remember here. In numerator, what is this? Q. D. Q means what? Charge.
Charge.
D means distance. Right? Okay. So charge is measured in
Coulomb.
coulomb. Distance is measured in
Meter.
meter. Volume is measured in
Meter cube.
meter cube. Meter divided by meter cube.
Meter square.
Meter square. And the unit of charge is coulomb. So it is only coulomb per meter square. Right? So remember, if you don't remember in examination also, the units are, they are asking 100%. Minimum one MCQ question is there from unit. They can ask you any unit from whole EME. Okay. So you should concentrate for this. And sometimes if you don't remember, you should know the formula. Okay. So from that formula, you can obtain the unit here. Okay. So this is unit of flux density also, d bar. So units of this polarization are same as that of the flux density d bar. Okay, so thus polarization increases, the electric flux density thus polarization increases the electric flux density in a dielectric medium. Okay, so electric field intensity is measured in volts per meter or Newton per coulomb. Remember, electric flux density d bar is q upon 4 pi r square. So unit is coulomb per meter square. Remember. And if you don't remember, you can somewhere at the top side of your notebook also, when I'm saying, you can just write such formulae. So if you go through any point, if you are going through any point, you just check there what you have written, then you can remember. Okay. So likewise also you can practice. So this polarization is increasing the electric flux density. Okay. So this point we have already seen. So when this polarization happens, it is increasing the electric flux density in the dielectric medium, and that increased flux density is given by this d bar is equal to epsilon 0 e bar plus p bar. Okay, plus p bar. So you know the relationship between this d bar and e bar. This is the equation we have already obtained. D bar is equal to epsilon 0 e bar, but there is additional p bar. Okay. So for isotropic and linear medium, this p bar and e bar are parallel to each other at every point and related to each other as, okay. So when we are considering the isotropic material, isotropic means what? Which type of material? Isotropic means when we are considering that the means if we check the properties of that material from all sides, these are the same. These are same. So that is nothing but the isotropic material. So when we are considering the isotropic and linear medium, okay, linear medium, this p bar and e bar are parallel to each other at every point and related to each other as P bar is equal to Xc into epsilon 0 E bar. Okay, the relation between this P bar and E bar is equal to Xc into epsilon 0 E bar, and this Xc is the electric susceptibility of material. So this question can also be asked, electric susceptibility. So this susceptibility means how sensitive is given dielectric to applied electric field E bar. Okay, means the material which we are using is how much sensitive, or it is nothing but it is showing the sensitivity of that material. Okay, it is showing the sensitivity of the material, that is dielectric material, to the applied electric field E bar. So when we are applying electric field, how much sensitively your electrons start moving. Okay, so that is nothing but the susceptibility. Okay, means you just in simple language I can say you that the accepting of that field. Okay, it is the acceptance of that field. So I'll skip the previous equation so that you will understand here. So what is d bar is equal to, this d bar is equal to epsilon 0 E bar plus P bar, right? Epsilon 0 E bar plus P bar, and P bar is equal to Xc into epsilon 0 E bar. So just put this in equation of d bar here. So we are getting here d bar is equal to epsilon 0 E bar plus P bar, and P bar is equal to Xc into epsilon 0 E bar. So take this epsilon 0 E bar common. So the remaining term is Xc into 1. And this d bar, so this d bar is equal to epsilon into E bar. This is for all type of materials, where this epsilon is equal to epsilon 0 into epsilon r. So this epsilon r is the relative permittivity, right? So this epsilon r is the relative permittivity, and epsilon 0 is the permittivity of free space. So this is the general equation. So when we are considering the free space, that time we are writing only epsilon 0 there. And the quantity Xc plus 1 is defined as the relative permittivity or dielectric constant of the material. Okay, so this Xc plus 1 is the relative permittivity or dielectric constant. Okay, so if they are asking you what they are asking you, the question, explain polarization. So if they are asking such question, you have to write first what is the polarization, and then sometimes if they are asking you the expression or equation for polarization, you have to explain this also. Okay, now we'll see one example on this. So everyone note the example. Everyone note first the example, because you have to solve here. So noted. Okay, concentrate now. So find the magnitude of d bar and p bar for a dielectric material in which mod of E bar is equal to 0.15 millivolt per meter and this Xc is equal to 4.25. Okay. So we have to find D bar and P bar. So what is formula to find D bar? D bar is equal to epsilon E bar, right? D bar is equal to epsilon E bar, and it is epsilon is nothing but epsilon 0 into epsilon R, right? So D bar is equal to epsilon 0, epsilon R into E bar. E bar is there. Then this epsilon R is equal to Xc in Xc plus 1. Okay, so epsilon R, find first epsilon R. Find first epsilon R, which is equal to Xc is given 4.25 and plus 1. So it is equal to 5.25. Okay, 5.25. Now put all the terms in equation of D bar. Okay, so what is asked? Find the magnitude of D bar. Magnitude means mod. If they are asking find D bar and P bar, then it should be in vector form. But what they are asking you magnitude. Magnitude means mod. Okay, remember. So this mod of D bar is equal to epsilon 0 epsilon R into mod of this E bar. Mod of E bar means its magnitude is given. So epsilon 0 is 8.854 into 10 raised to minus 12. This epsilon R is equal to 5.25 into mod of E bar is equal to 0.15 millivolt. Milli means 10 raised to minus 3. Okay. So here multiplied by 10 raised to minus 3. So if you solve this mod of D bar, you are getting as 6.9725 into 10 raised to minus 15 coulomb per meter square. Okay. So you first solve this and check whether you are getting the same answer or not. Shiv Sharan, roll number 46. Shiv Sharan, present. Akshay, Rani.
Yes, ma'am.
Okay, solving na example.
Yes.
Okay, and you just use formula of this P bar and tell me the answer also. But there you have to find the magnitude. So solve this. So find the P bar and tell me the answer. So what is P bar? Okay, all of you having formula? Yes or no? So this P bar is equal to XC epsilon 0 E bar. Now you can find. Yes, what is your answer? Okay, 5. Correct. correct.
5.6 44 into 10 raised to minus 15.
Minus 15. Correct. Correct. So Varsha, check this. I think correct. So they're asking such type of examples. You should know the formulae. Everywhere remember formulae only. Then you can solve the examples. Okay. So next point is boundary conditions. This is very important point because in first section also boundary conditions are there, and in second section also boundary conditions are there. So if you understand this one, you can easily understand from the second section, and again compulsory one question from this boundary condition. Okay, either derivation or example. If they are asking questions from this chapter, compulsory question is there on boundary conditions, so don't miss the next lecture. Okay, so thank you all and have a nice day. Now I'm ending the lecture. Thank you.